Hey friends, welcome to One Little Coder. In this tutorial, we are going to talk about a data science interview question, a data science machine learning interview question. This falls under the category of system design. So if you apply for any FAANG companies, Microsoft, Facebook, Google, most likely you would have a system design interview somewhere in the middle. So this particular video is going to help you how to navigate that system design. So especially we're going to focus on high level design. In system design, you can have high level design and low level design. So now what's the difference between high level and low level design? So high level design talks about a bird's eye view. So it basically tries to understand how do you think of the solution slightly at the overall level, and low level design would expect you to design the DB, design the API, design even maybe code, pseudo code. So low level design would be there. So in a system design interview, sometimes you might have a separate high level design, separate low level design. Sometimes you might have one system design interview which would cover all these things. But today we're going to focus on system design for machine learning project. So system design interview that covers machine learning project. This is sorry, this is a system design interview that happens for data scientists, senior data scientists, principal data scientists, and machine learning engineers, especially like I said, predominantly on FANG, MANG, whatever the new word is, like in those kind of companies. We're not going to do software engineering type system design first. This video is not about that. Second, in this video, we are not also going to focus on the machine learning part. We're going to focus on designing an end-to-end system. That is what we're going to focus. That's all. No software engineering, no machine learning. It's purely system designing. And this is like the first time I'm doing such a format. Usually, when people do system designing, they would do like a mock interview where interviewer would be there, the candidate would be there, so there will be question and answer back and forth. But I'm going to do I'm as you can see, I'm just one person, so this might be a little awkward. So let me know in the comment section what do you feel about this kind of new segment, like the data science interviews, covering data science interviews. So what are we going to design today? What is the question? So let us assume that I've appeared for a machine learning interview, machine learning engineer or a data scientist, and the system design is for machine learning project system design. So now the question that I'm being asked is design an end-to-end ML system to detect faulty mobile parts in manufacturing. So this is the question. Okay. So one of the important aspects, a very important aspect in which you are being evaluated in a system design is not the solution that you're bringing, not the technical expertise that you have, not the code that you're going to write. These are all important. All these are definitely important. But the most important thing in a system design interview is how do you think? How do you communicate what you think? How do you approach a problem? So that's entirely the primary objective of system design. It's there still to try and test your technical skills, try and test your technical acumen, like how do you design an architecture. But more importantly, what is your thought process? How do you communicate it? What kind of questions do you ask? And how do you optimize? So if you talk about Microsoft, I think Microsoft has a star framework, so you can Google online. I don't know if it is Microsoft or Google, but you can Google online about the star framework. So I don't remember the full form of it, but there are frameworks like this that will help you think. But all you have to do is remember your thought process is being evaluated, the kind of questions that you ask is quite important, and how do you optimize your solution, like the action part. How do you do it based on the questions and the answers? And also finally, how do you actually do the entire system design? That's very important. So given that this is the title, design an end-to-end ML system to detect faulty mobile parts in the manufacturing, now is the first time, like the time when the candidate should start asking questions. Like if I am the candidate, I would start asking questions to the interviewer. Like maybe I might I might show a screen like this, and then I might start typing, or I might start taking notes on my notepad, and I might start asking questions. So first I'm going to call it requirements. Okay, I'm going to call it requirements, or I can call it assumptions as well. So assumptions or requirements. The first thing is, where is this place? Okay, so this is the first question I would ask. Like when you say manufacturing, what is this? So the clarification would be something like mobile parts, like let's say camera or PCB manufacturing unit. Okay, manufacturing unit, manufacturing unit. So now somebody might ask us like, do you have if I ask them, do I have more context? Like for example, the next question would be, is it a brand new solution that we are going to build, or is it going to replace something that is existing? So now somebody might say it's going to replace an existing non-ML solution. Okay, so there is a non-ML, non-AI solution that is currently existing and it's going to replace. So now I would ask, can you describe more about the non-ML solution that exists currently? So what happens currently is there is a camera, okay, high definition camera. And that camera takes the picture of these parts. Okay, let's say in this case the PCB. So the mobile phone's PCB comes in, and the camera takes a picture of the PCB, and assume it is like high definition 1920 by 1080p. Okay, so this is resolution. There is a camera, there is pic snapping process, and the picture is saved on a local computer, a computer that is attached to the camera. So now this image used to be compared with the best, like the best pictures that they have taken previously. And if it matches with the best picture, the baseline that they have, that used to be called the correct PCB, the right PCB, non-defective PCB. And if any time there was a difference in the picture that is taken now with the baseline, then it is called defective. So basically, defective versus non-defective. Okay. Now I would ask the question, so currently what is the false positive rate? So that's what I would ask. So now, first of all, whether there is false positives and what is a false positive rate, or why in the first place they are asking for an ML solution? This is the question. So they are asking for an ML solution because the current false positive rate is quite high. So it's always good to clarify. Somebody says quite high, what does quite high means? Maybe let's say 30%. So now what is the new requirement? Maybe they want to bring it down to 10%. Okay. So this is, you have a system currently, a non-ML, non-AI based system, and that the false positive rate is quite high. The new system is ideally supposed to have 10% false positive rate. That's what you want. So now that you have some context about what is happening here, what is existing here, now you can start asking more questions that will help you design the system. So far what you asked, the questions that I asked is related to the context of the question itself. For me to better understand the question, for me to understand what was happening before. But now the new set of questions that I might ask, or you should ideally ask, is something that would help you in designing the system. Okay. So now, what I would like to ask is, when we say end to end, right? Everybody uses end to end. When we say end to end, what does it mean? Now the answer might be, there is a starting part, there is an ending part. The starting part is, let's say, camera. The starting point of the process is when the camera actually takes the picture, and let's say there is an ending point, which is let's say you send a message, okay, and the message would either have defective slash non-defective. A message, maybe instead of a message, we should say an LED light. Defective means there will be an LED light that is red in color. Non-defective means there is an LED light that is green in color. So now what happens when it is red? There will be a human inspector. Okay, there'll be a human inspector who would inspect this and then label it or whatever it is. So now this is the start, this is the end. So now you know what is end to end means. Now the next question is, do I have to design, like while I'm going to go through the design, do I have to explain or get into the machine learning part? Do I have to explain the model training as well? So model training, no. So this design right now, what we are going to discuss about, you don't have to do model training. All you have to do is give me the end-to-end system design, which means we are going to only talk about model inference, right? We are going to talk about only model inference. Now within model inference, do I have to, now the next question I would ask is, do I have to design, talk about API? Do I have to design about deploying the solution? Then I would say no, you don't have to talk about those as well. Your model inference system, let's say, is already, let's say, containerized, and you have an API endpoint. So you don't have to talk about how would you do model inference. Rather, you know that there is a model inference system is already containerized, and you have an API endpoint. So imagine like you have a box, like if you design a system end to end, where you talk about the model prediction, the actual prediction inference, at that point you already have this package. So you don't have to care about the accuracy of the model. You don't have to care about how is it the inference and all these things. Everything is there. Now what you have to do is, what are you going to do before this, what are you going to do after this? That's what your system design is going to do. So then the next question is, I would ask, do I have access to cloud, do I have access to internet? Okay, imagine like this is a manufacturing unit. We are not talking about an IT company, it's a manufacturing unit. The answer is surprisingly no. So you cannot use cloud, you cannot use internet, which means everything is happening locally. And in fact, it's happening on edge device. So mostly, so which means you need to remember that the solution that you're going to do is ideally supposed to be minimal, like tiny ML. So it is going to be on edge device. Okay, so now do I have everything that I want? I've got the starting point, I've got the ending point. I've clarified whether I need to take care of model training. No, I am going to deal with only inference, but I don't have to do a lot. And even within inference, like I don't have to deal with inference. In fact, it's containerized. I've got an image. I've got an API endpoint. So it's all well and good. Now if you take a pause, and the main thing is, like you see me in the video where I'm talking to you, you should ideally talk the same way to the interviewer. So like, in this video I have played the interviewer role, the interview the candidate role slightly, but I would suggest you to do the same thing when you are actually being interviewed. You should be constantly talking. I mean it's fine if you take a minute or two, a pause, gather your thought, take your notes, see all those things. But I would still encourage you to actually talk, like talk aloud with your interviewer, so that the interviewer knows what kind of things are going inside your tiny little brain, and how they can help. And most good companies expect system design, especially high level system design, to be a collaborative effort, because that's how you're going to ideally work in a team, right? You're not going to be the full stack developer who is going to design this entire thing in the real world. You're going to be probably a small part, like a machine learning engineer, a database architecture, or a data scientist, something like that. So keep in mind that they are also expecting you to see how you can collaborate well with the team, how you can communicate, challenge, like how if they challenge you, respond. So it's very important for you to constantly talk. Now I think I missed, like we already have some idea about the accuracy. But one thing that we need to remember is, we are talking about edge devices. We have to reduce the false positive rate by 20%. So that means there is an important thing that we need to discuss, which is what is the ideal time, and the solution was already there. So what is the ideal time that your solution could take from start to end, right? You've got start to end, right? You've got start to end. What is the ideal time that your solution can take from start to end, right? So now the answer to that question would be, let's say, 10 seconds. Why 10 seconds? Because this is an assembly line. Okay, every 10 seconds there's a new PCB that is placed. Imagine, like, think of yourself in a manufacturing unit. There is a conveyor belt. So every 10 seconds you get a new PCB. So after the first PCB passes, you have 10 seconds to decide whether it is defective or non-defective. Let us say if it is defective, it goes this side. If it is non-defective, it goes this side. Or if it is non-defective, like you said, defective, you put a red light. So there is a manual inspector who would take this rather than leaving it in the conveyor belt. So imagine such a system. So you have got basically 10 seconds from your starting point, the time when it takes the picture, till the time it can lit the LED. So that's how you see the 10 seconds. So this 10 seconds is quite crucial when you design the system. Now at this point you can start designing. Now you can ask the interviewer, would you like me to open like a Miro or a draw.io, tldraw.com, like this kind of whiteboarding solution, and then start actually drawing the architecture, like the design? Or would you like me to talk you through? So everybody might have a different preference. Somebody might like to see your notes, somebody might like to see the screen. It's different preference. It's always good to clarify. So let us assume the design the interviewer has told us to actually go design it. Okay, so now is the time when we are going to design. So what is the starting point? A starting point is we have got a camera, right? That camera is taking a picture, right? And that camera takes a picture. So now imagine this is 920 by 1080p. So which means we have let's say our image is, let's say, like a 5 MB image. Okay, so you either can assume that it is a 5 MB image, or again you can discuss it with the interviewer. So like, what is the image size? And let's say it's a TIFF image. So you've got for simplicity I'll stick to JPEG. So there is a camera, there is a 5 MB image been taken. So after this image is taken, so now the next step is it goes inside a computer. Okay, so this image is now stored inside a computer as a file. So let us say this part has a part ID underscore, let's say there is a date 2022 something dot JPEG. This gets stored in the computer. Let's say this is a computer. How do I draw a computer? Like this, look like a computer. Okay, so let's say this gets stored in a computer. Now I'm going to suggest I'm going to create like a folder, watch folder, or a file watcher. Okay, I don't have much icons here. So let's say I'm going to have a file watcher. I'm going to call it a file watcher. So what this file watcher is going to do is, in a particular folder, the computer or a server, it's going to look for a file or look for something new. It's going to always keep on looking for a new file. When the new file is dropped, so it's going to trigger something. So this is very similar, like if you have used Google Drive on your local machine or a Dropbox on your local machine, it's always looking for some file to come in. The moment it comes in, the file comes in, it will start syncing with the cloud. A very similar way. So I'm going to have a file watcher, and the file watcher is going to look for the file. Let us say that now at this point, the file has come in. Okay, so this file has come in. So now remember, we have 12 seconds to design our entire, I mean like to run the entire process. Let's say this is totally 12 seconds. So this is 12 seconds. So now let's say after you see the file watcher, so now let's say the file watcher knows that the new file has been dropped. Now what are you going to do? I have multiple options. I'm going to spit it out or speak out. What are the options that I have? I can take the file, right? We have a JPEG file. I can move the file. I cannot do, okay. So one of the thing is, can I call the API from this machine? Okay. No, you cannot call the API from this machine. Which means you need to move this file from this machine to somewhere else, the edge device, let's say. So now I have two options. I mean, you might have multiple options. Please let me know in the comment section. So one, I can take the JPEG file and move the JPEG file. So the actual JPEG file gets transferred from this machine to this machine. Option one. Option two, instead of moving the JPEG file, which could be again a 5 MB file, so now you have to optimize your IO, your data transfer speed, like what kind of connection you are using. It can lead to a lot of questions. Or that is if I have to transfer the JPEG file itself, or I can process the file here, convert it to binary format, move the binary format as a payload, right? So now you can lay out this two options to the interviewer and ask which one they prefer. And I would probably prefer the second option, which is to say that after the file watcher notices that there is a file that is dropped, this file is now being converted into a binary format. Okay, so your binary format, let me write a big B, let's say it's like an numpy array or something like that. Okay, by numpy material drawing skills. So let's say we have a numpy array or a binary format ready. So now we have taken the file, converted it. Now you have to transfer this to the edge device, like where the scoring mechanism is going to score whether this is defective or not defective. So what do we have? We have a scoring engine that's coming somewhere. We have a scoring engine that's coming somewhere here. Okay. So can you directly go to the scoring engine? No. So first what you have to do is you have to take this and then send it to a message queue. Okay. So let's say we are going to send this to message queue. Now that message queue is going to send this to the scoring engine. So by sending it to the message queue, you are relieving this entire set so that they can be free. They can be free in whatever they want to do. Maybe, you know, new item is coming, whatever it is. So they are free. They are not occupied. So you take this content, send it to the message queue. Now, when you're going to send it to the message queue, how are you going to send it? I mean, you need to send it as a message. What is that message is going to contain and what kind of format that message? This is either you yourself have to say or the interviewer might ask you. So now I'm going to call it a message, and this is going to be my message queue. So I would prefer this message format to be a JSON object. So now the next question would be, what do you think this JSON object would contain? So what do you think this JSON object would contain? So I would keep three things. I would keep the name of the file, I would keep the timestamp, and I would keep a binary format, the content, actual numpy array or whatever. Now the question is, why would you keep timestamp? Why do you need timestamp there? Again, always take time and think. So I would keep timestamp there because sometime in the future, I would want to see how the system has been working. I'm designing an end-to-end machine learning solution system. There could be model drifting happening. There could be higher false positive rate. There could be places where my prediction has been really terrible. So my data science team might want to come back and see what was happening. So timestamp is quite important for me. Let us say, just for the sake of discussion, that in a day, back to back, like let's say 50 items are getting high false positive. So now what I would, like if I'm a data scientist, what I would want to see there is, I would try to see during that particular time if something is happening. Maybe somebody is switching on an extra light. Maybe somebody is doing something else. So timestamp is quite important for me. Why do I need the file name? The file name is actually linked to the part ID. That would help me track the part. Maybe I can say, you know, like if I have like different sources of the parts coming in, I can say one particular source is always problematic, then I can go there and fix the stuff there. So this will help me do those things. And again, once again, like I said, it is quite important for you to be explicit and then say why are you making that assumption and then how is it going to help you in this design. So I'm going to send this payload as JSON, and it's going to go to the message queue, and the message queue is going to go to the scoring engine, and from the scoring engine you're going to make an API call. Okay, so now we are almost done. Now the problem is you need to start putting arbitrary numbers against these things. So like the entire process is ideally supposed to take 12 seconds, right? So let us say now you can either ask the interviewer again, or you can come up with yourself. So I can say, you know, this computer, this camera to computer, this takes, let's say, 3 seconds. Let's say taking picture itself takes 3 seconds. It's a high resolution image. And then next is, let us say that computer saving is like 1 second. So processing the file into binary format is, let's say, 1 second. And payload, creating payload and sending is, let's say, 2 seconds. So how much time we have spent? 3 plus 1 4, 4 plus 1 5, 5 plus 2 6, 7. So we have literally 5 seconds remaining, and in that 5 second we also have to let the LED, okay, green or red, whatever that color is, green or red. Is red. Yeah, so you have to do this as well. I'm going to put, if the message transfer takes, let's say, 2 seconds, I'm going to put 2 seconds here for this. Okay. So now, given that I had 7 plus 2, 9, 9 minus 3, sorry, 9 minus 12, 12 minus 9 is 3. So all I can use is 3 seconds here. So now the question, important question to you is, are you just going to make an API call and then say my job is done? Or on the other hand, whenever you design a system, one of the things that also people like to see is, how do you handle failures? How do you handle errors? How do you think long term, like when something is going to happen in the future, do you account for it? How do you minimize technical debt? Of course, always these things. So now what I would say is, whenever I'm going to make an API call, I can have three result. Okay, let's see. Whenever I can make an API call, I have success, I have failure, I have no result. What is a success? Success, I got what I want. So I got either 0 or 1. Failure, API call failed. I got an error message. No result, nothing came. Nothing happened. Maybe the internet broke or something. So now success, quite good. You make an API call, you're getting either 0 or 1. Failure, okay. So the 0 1 also is something that you should not automatically assume. Ask the interviewer always, like what is the format in which you get output and all those kind of things. Failure, there must be an error message. So how will you first identify whether something is success or failure? I would say that this box has already taken account of it. So I would use, HTTP status code 200 as success and anything else as failure, and not hearing back from them is no result. So now success is easy, failure is easy. But when you want to do no result, in APIs there is something called API retry limit. So how long you are going to do the retry? Now that is an important thing, because you should say that you can retry maximum for 3 seconds. Why? Because this is a conveyor belt. If you're taking more than 3 seconds to retry, it's highly likely that you are messing up this workflow. So keep either 3 seconds or less than 3 seconds, like the time limit for API retry. So you have success, failure, no result. Based on that, you're going to do the final thing. So you either light the green color or light the red color, and that's done. So now certain things that you can discuss is, like I said, like what is the API call result? I would say it's a JSON object, which has whether it is, like what kind of result it is, and also the value of the result. 0 and 1 we can always debate. In a good machine learning solution, 0 and 1 is always tricky. So I would prefer like probability preference for probability score. Now the interviewer might ask you probability score, that now the interviewer might ask you like, why do you think so? So now I would say, like in a typical 0 or 1 classification class, somebody has already made the assumption that 0.5 is my cutoff, and then they've done it, but it doesn't give me the flexibility to do it. So maybe, like what 0.4 is a better cutoff. I'll get to know after I look at all the data. So I would go with preference. My preference would be for probability score. That would help me. The next thing is, whenever you design a machine learning solution, I would always encourage you to keep two things in mind. One is ML logging, like how this entire thing is going on. So you log like ML logging or monitoring. I would say ML logging, ML monitoring, model monitoring. So mostly, monitoring model for crazy behaviors like drift. And finally, I would do ML feedback. One of the important things when you design machine learning solution is you always want to improve it. Like at some point, you have to retrain this model. This model is not going to exist forever. So at some point, you need to retrain this model. So thinking that at the start of your high level design will always is always good. Whether you're doing this for interview or whether you're actually doing this at your workplace, keeping these things in mind is always helpful. Like how do you retrain the model? How frequently you retrain the model? At what point you retrain the model? Before even you retrain the model, how do you make the call that you have to retrain the model? How's the model doing? Is the model drift good? Is model behaving weird? Just basic logging so that you can put it in Splunk, or you can send it to some kind of visualization tool and then start looking at it. So these are certain enhancements that you can talk. So overall, to quickly design, share the solution. So we have a camera system, we have an LED system. We want to take a picture, or we have like a machine manufacturing system where the picture of the mobile phone part PCB is taken, and you want to implement an AI solution that takes this picture and then says whether it is defective or not defective. And yeah, so you have got different workflows. There is a computer where the image is stored. There's a file watcher that looks for the file, and there is a process. Now the file watcher would trigger, which is to convert that, digitize the image to be precise. And that digitization process, after the digitization, you send this as a payload, as a JSON file to the message queue. The message queue sends this to the scoring engine, where the API call is made, the score is retrieved, then the LED is triggered. This main set is actually on edge. You have less time to do it. You cannot take more time than what has been defined to you. And also, importantly, you talk about like importance of probability score, not just 0 and 1. Importance of logging, importance of model monitoring, importance of ML feedback, like when do you retrain the model and all these kind of things. And I think that's it. We are at the end of the video. If you happen to attend a machine learning interview or a data science interview, and you are in a high level system design interview round, I hope this video will be helpful. Or if you have already have experience of attending a machine learning system design interview, or system design interview covering a machine learning project, definitely let me know in the comments. The most common questions that I've seen is usually mostly digital questions. So design a recommendation engine, design a ranker solution, design a search engine, design an auction platform. How would you handle like design a machine learning solution, machine learning system powered marketplace. So these kind of the questions that people would usually ask. Sometimes people would focus on the ML part. Sometimes people would focus on like the holistic thinking, like what we are doing here. But I think either way, this is a fun activity to do it with a very good interviewer. So yeah, if you happen to appear for an interview, I wish you good luck. If you have any comments, let me know in the comment section. Otherwise, I hope you stay safe. Take care. Peace.